Binary, base 2. It's what you've all been waiting for. Here it is. In doing this research, I was very surprised to learn that binary dates back to the 16th century in Europe. Base 2 numbers appeared in ancient Egypt, China, India, long before computers came to be. You know, the first digital computers were around, 1942, and in the 50s got popular in the 60s. So I would have expected that the base 2 math system would have been just before that time. I would have expected it to come out in the 40s or something like that. But isn't that always the case? That the dream, the concept, the research precedes the making of the physical computer. I mean, we dreamed of going to the moon and going to Mars long before we ever landed there. So binary is the lowest base number system. There is no base 1, there is no base 0. Base 2 has 2 digits, 1 and 0, on and off. It's the perfect mathematical representation for digital circuits when you think about it. Now, George Boole is somebody that you should know because he was a famous mathematician, philosopher. He was born November 2nd, 1815. He died in 1864 at a young age of 49. But to this day, computer languages have the Boolean data type, which can only be set to 1 or 0, sometimes yes, sometimes no, sometimes true, sometimes false. Isn't it interesting that the Boolean data type in all these different languages is not the same? In C or C++, you can add Booleans together because it's like a 1-bit integer. In C#, it can only be true and false. There's no addition to it. And in Objective-C, get this, you can only set it to yes or no. So not all Booleans are created equal in all languages. Now, are you ready for the magic? Because everything you know about base 10 is about to change to base 2 by simply changing the 10s to the 2s and removing 8 of the symbols. Here we go. The columns are now 2 to the 0 power, which is 1, and 2 to the first power, which is 2, and 2 squared, which is 4, and it keeps on going. It doubles, 8, 16, 32, 64, 128, and so on. And there's only 2 symbols, as you would expect, 1 and 0. In base 2, I'm sure you heard of bytes. A byte is a group of 8 bits. A bit is a binary digit. Just like a digit in base 10 is a decimal digit, B for binary means a binary digit. And here's some numbers. We can see the arrow pointing to 0, the arrow pointing to 1. 0, 0, 0, 0, 0, 0, 0, and a 1. That represents the number 1. And so forth. Got 4 zeros, 2 zeros, and a 1 0 for the number 2. There is no 2. 1 and 0 make up a 2. It takes 2 digits to make 2. It always takes 2 digits to make that base. Just like base 10 takes 2 digits, a 1 and a 0 to make base 10. And base 2, the 1 and the 0, make up a 2. And 1, 1 makes up a 3. We got 252 where the arrow points to. The arrow is pointing to the last row of 1, 1, 1, 1, 1, 1, 1, 1, or sometimes you hear it as FF. All the bits set in that byte have an unsigned value of 255. Remember our number 123? What does it look like in binary? It looks like 0, 1, 1, 1, 1, 0, 1, 1. Because if you add up the 64 column, the 32, the 16, the 8, and the 2, and the 1, you get 123. Notice we skipped the 128 column because it's larger than 123, so we have a 0 in the leftmost column. Then we have 3 1s. And we skip the 4 column because it just doesn't fall out into place. And those add up to 123 decimal. Okay, here's things you should know, your cheat sheet. First off, you should know the binary weights of the columns. Counting from right to left, they just keep doubling. 1, 2, 4, 8, 16, 32, 64, 128. Those are the weights of the columns in a byte. They can keep on going. The next byte would be 256, 512, 1024, 2048, and so on. But at least commit to memory the 1, 2, 4, 8, 16, 32, 64, 128. And then of course, all zeros is 0, 0, 0, 0, 1 is a 1, 3 ones make a 7, 10 is like a memory peg point that you should know because it's 1010 is equal to 10. The 1010 is the 1010 in that right side nibble column. Many times a half a byte is called a nibble, N-I-B-B-L-E or N-Y-B-B-L-E, as sometimes I would call it. The highest number of an unsigned byte is 1111, 1111. 8 ones for the value of 255. You should know that. A byte has 256 possibilities, from 0 to 255. Just like a 2-digit decimal number has 100 possibilities from 0 to 99. The highest digits are in the highest number with that many places. Same thing with this. We have 8 places and we have the highest digits, which is all ones. If the number ends in a 1, if a binary number ends in a 1, it's an odd number. It just has to be. If it ends in a 0, it's an even number. Next, we'll do some worksheets and work through converting decimal numbers to unsigned binary numbers.